Okay, well, thank you everyone for your time today. I'm Trisha, one of the founders as well as the CEO of Unit 21.
And I'm Nick. I've been working with Trisha as a software engineer for quite a while now.
We're going to be talking about data in dynamic systems. Today, we're mostly going to be talking about a few different concepts. One is really the challenges with engineering in fintech that are different from engineering in just any other tech company. The second is the key strategies that we've deployed at Unit 21 and our previous companies to really tackle issues with data when things are constantly changing. To give a little bit of a background, previous to Unit 21, I worked at a firm, and I was a fairly early engineer and got a chance to build a lot of the original systems over there. And I also wrote the first version of Unit 21, and of course, we've been very fortunate to have engineers like Nick really build out the system to what it is today. And we're really sharing our experiences since it's something that is not really talked too much about in what is so difficult about engineering in fintech. First, some background. We are a Series B company. We build no-code toolsets for risk and compliance operations teams, really focused on fraud and anti-money laundering. We work with companies all around the world. Some of our customers include companies like Chime, Intuit, Twitter, Gusto, Coinbase, where we've really had the opportunity to capture significant fraud, $100+ million of fraud since we launched in 2019. And we handle 2 billion+ events per month. That's obviously great, but has led to a lot of significant challenges in scaling that we're really excited to share more about and dive more into. So first is what really makes engineering difficult in fintech. The biggest component is engineering. The expectations for a regular software company are very different compared to that of fintech companies. So I took some screenshots of for other software providers or other software companies like Facebook, TikTok, DoorDash. When there are issues, there are actual blogs about how do you get around those issues. Whereas for fintech companies, if there's an issue, then customers are really, really unhappy. And so people really expect this degree of consistency from their fintech providers that just does not exist with other software companies. And therefore, consistency is far more important than availability in fintech from a transactional database perspective. This was really, particularly, we realized this significantly when our customers, for a lot of people, they are their primary checking account. And they tell us that, in the event that there's any system downtime and they are not able to be, available for their customers, or if the balance is incorrect on their account, then customers get really mad because they'll be sitting at a gas station and then they have to wait for 3 hours till the bank fix the issue. So the expectations are really different, and it's quite underrated how the different expectations means that from an engineering perspective, you really prioritize different things. The second is legacy systems still run the show. For any fintech company, you're working with several legacy systems, whether it's payment providers, data providers. Even if it is through an aggregator model, it's behind the scenes. That exists today, and the problem with legacy systems is that they still are ultimately ruling what the data sources are for fintechs or how payments are initiated and moved for fintechs. The cost of ongoing maintenance is significant for any legacy system. We find that there's 1 to 3 engineers that need to be really full-time to maintain that system, so it's not just a sunk cost for a one-time effort, but really for continuous maintenance. And with an engineer salary alongside benefits and equity, it really starts getting into the millions of dollars. The Second is that there is no real source of truth. This is really the founding rationale behind Palantir, where there is no concept of a unique user ID. And so different systems are going to be having different concept of what a user is. And ultimately, the fintech will need to write significant ETL processes in order to be defining what the user ID is. And that's why Palantir is successful and is able to be the company it is, because that is really what they're doing, is providing a unique user ID. The interesting thing about that is also that in the absence of a unique user ID, companies often use things like phone numbers or SSN, which also has another several issues with that, because there is often not that true unique user ID concept, and that really starts cracking up in the starts like showing cracks in the actual system reliability. The third is that product development cycles are longer. Not really surprising, but for any of these legacy systems, there are updates to the UI, updates to their documentation, updates to just their internal systems, and their error rates are really, really slow. But within fintech, this is a reality that we have to live with and accept, that these are the systems that we are going to be working with. And the third is compliance begins before the company begins. You need compliance in order to launch. Before we even had any customers, we had to get SOC 2 compliant. So the table, or the screenshot that you see in the right was like 110 checklist procedure that we had to fill out before we had any customers. And before we had any data, we had to show how we have different change management processes and risk mitigation processes, et cetera. So it's really important, because without having these different compliance attestations, you can't really launch as a company, since your sponsor bank or your customers are not willing to really work with you. The second is you need this in order to continue and to exist as a company. And so it's not really, again, a one-time, in the beginning you do this and then you don't really think about it again. You have to continuously keep compliance in the forefront. Auditability and explainability are of paramount importance. This is something that, again, for regular software companies is just not that important. If you don't need to show that all of the actions that the user is taking on a particular page in an auditable, exportable form to the user. But with fintech, you have to. And the fourth is personnel. There is really a much higher standard for personnel compliance. Everyone has to have a background check. Everyone, for any kind of permissioning, you really need to have audit logs of the ticket. There has to be a Jira ticket associated with it, and you have to have it approved by certain team members. So those are the three main things that are really unique about fintech and engineering in fintech that just don't really exist with other software engineering companies. And because of that, when people often come from a Google or Facebook, they wouldn't often appreciate why engineering in fintech is this complex. So we'll talk about a few strategies that we've put in place to really make sure, from a reliability, from a customer perspective, as well as the engineering culture and compliance, what we make sure that we have in place to really make sure that we are actually successful from a fintech perspective. So the first is migration strategies. So why do you need a migration strategy? For migration strategies, the main aspect really to keep in mind is that most people think that, oh, you need to do a database migration only when the company is really large. And that's not necessarily true. Your schema is going to be modifying every single day, because you'll constantly be changing as a product as you gain product market fit. So in the beginning, what your product looks like is going to be very different from when you actually have scale. The second is there will be new product lines. You will expand potentially from a geographical perspective. You will maybe enter into new different businesses. And because of that, what your database representation of the schema is also going to be changing. The third is you may collect additional data. For example, you might collect IP address information or device information. Or you may have been collecting that in the past but not actually persisted in your databases. And the final is unknown unknowns. It's really difficult in the beginning to know what the ideal database schema will be like. And only when you actually have customers or when you actually have users, you realize what you don't know. And then you have to implement those particular migrations to make sure you are actually having a database that makes sense. So what is a successful migration? The first is that the migration needs to be complete. That means all the data needs to be completely migrated over. The second is consistency, which includes transactional consistency. So if the database says that last night I had $45 in my bank account, tomorrow morning, assuming I've not made any transactions, I still have $45 in my bank account. There is no data loss, so it won't show that I have $23. And there's no data duplication, so it won't show I have $90. The third is the migration needs to be testable. So especially for more complex migrations, it's really important to be able to test it, to really make sure you have that idempotency in the event you need to repeat it in case if there's a failure. And the fourth is that the migration needs to ensure that there's no downtime. Your custom operations still need to run, your business operations still need to be able to run, and you need to be able to do that while you're doing a really massive migration. So we'll be talking about write both migrations for this particular migration strategy. So let's say you have a table with a sender, a receiver, an amount, and now you are expanding from a geographical perspective. So you add another column called currency. This is actually a fairly simplistic example. Obviously, migrations can be really, really challenging. One of the migrations that I did at a firm was really moving it from a model where we really thought of loans as potentially a 3-month loan to really any term length loan, which was a really challenging migration that took multiple days. So let's say you are doing this migration and you want to make sure that initially the reader is reading from the sender receiver amount and now also reads from a currency column. So the way that it will work is today there's a writer which is going to be writing to the database, and it's going to be writing that Jack Dorsey sent Mark Benioff $50, and then the reader is going to be reading these particular transactions. The first step is actually to make sure you have dual write schemas. So you write to the old database as well as to the new database. And the new database is now including the currency column. And so it's a multiple, you're writing twice really, while you're reading only once because the data's not been migrated over. The next step is actually the migration, so backfilling the data from the currency column for anything that is null and then which really represents the old data into the new data format. And this, again, can be very simplistic. It can take just a minute or a few seconds, or it can take multiple days, depending on the type of overall of your system. And then finally, you can swap once all of the data has been backfilled from the old data schema to the new data schema. And so now you can really throw away the old schema, make sure that everything has been migrated. At the same time, because you're constantly reading only from what has not been migrated completely, you ensure that there is no downtime. You ensure that the custom operations can run as expected. So that's with respect to migration strategies. We'll talk about 2 more strategies, and I'll hand it over to Nick.
Yeah, hi everybody again. So, a lot of what Trisha just walked through and talked about and mentioned here, there's a lot of obvious difficulties and there's a lot of difficult compliance points. But, one key difficulty when you're trying to bootstrap a company out of everything is, it's in direct conflict with what's usually the best business strategy, which is get features out, get them in the hands of your customers and start iterating and figure out what's best for you. And, there's a lot of other problems in that area. So, when you're an especially small company, one thing I've noticed, especially in the hiring direction, is it's really hard to get senior engineers, and especially for us, getting a number of good data scientists and data engineers was exceedingly difficult, whereas, we could hire about as many junior engineers that, were ambitious, talented people as we wanted. But senior engineers took a little bit more time. It wasn't even a money problem. It was more just convincing them we're a good product and just bring them on board. Beyond that, with that fast, dynamic kind of changing experimentation, there's a lot of specific metric needs, capturing, say, your time of going from A to B, from open to close, from pending to complete, key business intelligence metrics or key just general things you need to know. And as well as, the fact that your feature set is changing. So, a lot of the things that we did at some point in time were experiments, hacks, or temporary partial implementations. And, what are you actually doing with that is very important. So, being in the compliance space, we have very specific things. It's 100 acts that we have to follow where we need to store records for basically 5+ years for whatever situation. And, that kind of need kind of can permeate your thoughts a lot, right? So if, depending on exactly where in the stack you are, deeply into transactions, you have to do this very well, and you have to do versioning very carefully, and you have to be able to reconstruct things 5 years in the future. But, I distinctly remember a time when 6 months felt like an obscenely long time period to be thinking about because, well, we had a run rate. So expanding on that and, just thinking through what 5 years in the future looks like, there's a ton of problems with versioning, in the direction of, kind of experiments and, hacks or, testing features, right? So Trisha was mentioning earlier, what happens when you add a column, that's relatively straightforward. But, what happens when you, say, deprecate or remove a feature or you actually remove data? You go through a bunch of different schemas which don't necessarily map to each other, and you have to figure out how to inject meaning into those kinds of things, and there's a very, very wide range of options on your data storage stuff, and it's very unapproachable, especially from the perspective of trying to move fast. So, for us, there's a ton of things we experimented with, and, some of them didn't go so well, but distinctly for us, we needed metrics both for the business intelligence side and just for the, kind of auditability of it that weren't necessarily in the transaction movement, but were often in the direction of things like, user-employee actions or just specific metrics, right? And, I've talked to a lot of you, and, a lot of you have needs like this. So, I recall one company was working on, payments between landlord and renter and, tracking some of those interactions when, you might have an experimental flow going on. You might need an audit record of that, and you might not need it to the same degree as, transaction data, but the thought process permeates. So, I think one of the big mistakes Unit 21 did was, we had some very, very smart data engineers, and, they start working on, transaction history, and they start getting into a certain mindset, and, they start doing the cardinal sin, which is building and optimizing an extremely complex system, which isn't actually needed in the first place, right? So a lot of what we did was we would track every single schema change, and, we're a SQL house, so, we actually track every single individual update and, capture all those different schema changes. But, with the mindset of, well, this feature doesn't exist in 3 years, or, there's an intern pulling through this data 3 years later, it kind of ends up being useless and not really worth all that effort. So what we had to do really was kind of go back to the drawing board and, outside of the transaction direction, why are we even doing this kind of record keeping? Is this a core competency? Is this a core requirement? And, what skill sets do we have? So, a lot of good coders, not a lot of data engineers. That's an important consideration. When the database is exploding at 3 a.m., if you only have 2 people capable of fixing it, that's not good. So ideally, you want off the database in that case. So, what worked for us especially well was just focusing on application-based change capture. So we're a SQL Alchemy house, so, we use an object relational mapper, which, is a great productivity booster, and we can build that out really fast. So rather than, focusing on, SQL triggers or all sorts of fancy change capture, what we actually ended up doing was building a wrapper over our ORM that one, captures, a before-after state in the state that we want it, but, two, just by the nature of being in the application was a lot easier for us to work for because pretty much every dev we had could code, pretty much every dev we had could write unit tests, actually look through, read it, and understand it, whereas that might not have been true for entering a production database. It's a different skill set, right? And a key point here is what this actually allowed us to do is focus on user digestible records. So rather than just capturing the state of the schema and having, say, a bunch of foreign keys or whatever we use internally, we actually focused on key points like who did this change, what was the time of it, what was some metadata details around with it, and then we save it in a kind of before, after, what was the input, what was the output, what was the result of this action, and key point, we try to get the schema to be in a self-documenting state. So rather than having to maintain 1,000 different versions of a schema and looking back 10 years later trying to figure out what on earth Nick Miller was trying to do way back in the day with some feature that was, just dropped 6 months later, well, it's just readable. And as long as you know what, outcome, text, and whatever the details around your business are, that works exceedingly well for us. And a key point here is, I hate application-based change capture despite the fact that I built it out. But just the reality of it meant everybody could work on it, it meant everybody could understand it, and I didn't have to get pinged at 3 a.m., made it a pretty big W for us when we were a little bit less well-staffed. So besides that, these things kind of permeate your culture, and it permeates how you actually end up working. So, just sharing a little story here. When I got involved in tech for the first time, I got my first internship, and I went to not a fintech company, but a kind of fintech adjacent company. And, as an intern, I thought it was a great gig going in. I had a specific project, which was basically building out a bunch of kind of credit risk scores based off of all sorts of fancy data calculations, and I was super stoked on it. But what ended up happening was, the company was 20 years old, there's a bunch of legacy reasons, there's a bunch of data complications. So what kept happening to me is I kept having to go through a very, very slow approval process for what seemed to the intern to be relatively simple things like adding a column or adding some queries to some database somewhere. And what that kind of merged into is I didn't get anything done. And all that enthusiasm, all that intern ready to go start applying what I was learning in university just dried up pretty quick, and it turned into just turned into another boring college class that I had to do the bare minimum to pass to look impressive, and I started thinking about, okay, I'm gonna go off to the hot new tech idea of whatever 19-year-old me thought was a great idea in 2019. I think Google Glass was the pick at the time that didn't really work out. And I mean, just beyond this, the fastest way to make me leave your company or any of your engineers is to stick them with some boring maintenance project. I will leave you fast, and I would not leave that. So, I really want to pound this down of, ask yourself, why are you doing this constantly? And, what are your core competencies, and why do you have to do that? So besides that, I think you got it.
Yeah, well, firstly, if you have any questions, feel free to email Trisha at unit21.ai or Nick at unit21.ai. We're hiring very aggressively across engineering, product, sales, marketing, operations. Feel free to check out our careers page. And if you're interested from really a collaboration perspective for fraud, anti-money laundering, identity verification, let us know, and we'd love to help. Well, if you have any questions, feel free to ask, or we can take it offline as well. All right. We'll be outside. We have a booth, and come say hi. And thank you again for your time.